this lesson, we're going to learn how to do set and interval notation and just how to write it in that format, and then we'll apply it to our piecewise functions later. You will use your 2-6 notes day 1 for this lesson, and you'll do problems 6 through 12, so those are copied on here. Set and interval notation are two different ways that we can do domain and range. For today, we're just doing domain because we're going to be given just inequalities. And then when we apply it to our graphs, we will be doing domain and range. So set notation is pretty much the easiest one, I think, because all you're doing is kind of copying what they said in the original here. We're going to use inequalities in set notation. So for your domain, you would always say values of x such that line means such that, and then you just basically repeat what was said up here. Values of x such that x is greater than 5. That's it. That's set notation. Pretty straightforward when you're given a problem this way. Interval notation is a little bit different because you're going to talk about where the values touch on a graph. So what are possible values for this inequality? If you think of it, if you have a number line, this is how you used to graph these. And I have 5, 6. Oh, why am I going down and up? There we go. If we used to graph this, we'd say x is greater than 5. So we go to 5 and have an open circle. Because remember, greater than less than is open circle, greater than equal to less than or equal to is closed circle. So I'm going to have an open circle, and then I would say I shade all the way across because it's greater than 5. That's every number, isn't it? Somebody used to make that big arrow and say, okay, it goes on forever. Well, that forever would be called infinity. So in interval notation, you say, where am I shading from? Where's the start to finish? So I started shading at 5, and I stopped at infinity. So I'm going to go 5 to positive infinity. Now, one of the unique things about interval notation is that if you have an open circle, so a greater than or a less than, you actually use brackets around your 5. If it would have been a closed circle, meaning my symbols were greater than or equal to, less than or equal to, I would use a bracket. And then infinity, positive or negative, we will always use parentheses. So this is my infinity. I will close out with a parenthesis. So in interval notation, you're saying that the values that work for this inequality are 5 all the way to positive infinity. And 5 is not included because it's a parenthesis, not a bracket. So let's try number 7. This one now, 5 is included. That's the only difference, right? We have a line under there now. It's greater than or equal to. So my set notation is the same. Values of x such that x is greater than or equal to 5. No big deal there. Interval notation is going to be pretty much the same. All that changes is equal to 5. So we'd still have it go 5 to positive infinity. But now because it's equal to, we will use a bracket here. And the infinity symbol always gets a parenthesis. So that's all we're doing with that one. Not much different than the last. Number 8 now, you'll see that x is between 5 and 7. And in 9, x is between 5 and 7, but it includes 5. So for 8, my set notation, I'm going to say the same thing. Values of x such that 5 is less than x is less than 7. I'm basically copying the original problem. For interval, think about this on a number line. Here's 5, here's 7. If x is everywhere between 5 and 7, but doesn't include them, because it doesn't say less than or equal to, I would shade everything in here. So I start at 5, and I go to 7 with my shading. Since it's a less than symbol, 5 is not included, and neither is 7, so I use parentheses. The only difference then for number 9, set notation, values of x such that 5 is less than or equal to x is less than 7. Same symbols I've been using. Interval notation, now it's still between 5 and 7, but the 5 is included, so I'm going to use a bracket there. Number 10 looks a lot like 8 and 9, except now 5 and 7 are included. So hopefully you could figure out values of x such that you're going to write it the exact same. 5 is less than or equal to x is less than or equal to 7. And then again, I'm going to go between 5 and 7, but because there's an equal to sign under those less than symbols, they both get brackets. So 8, 9, and 10 are very similar. It's just whether you use the less than sign or less than or equal to. 11 now, here's where we introduce the word or. Or in set notation is okay to use. So I'm going to do the same thing with set notation. Values of x such that x is less than 5 or x is greater than 5. Basically not equal to 5, right? In interval notation, notation now, I'm going to think of this as a number line. So here I have x is greater than 5. There's 5. Shade everything forever and ever. Oops, sorry, I did less. I did the second one first. I better go in order. X is less than 5. Let's start with that. How about? So here's 5. X is less than 5. There's one option, or x is greater than 5. The word or in interval notation, we use the symbol union. So that's a union symbol. It's just a big U. And so we will start by saying, okay, this first shading right here, where did I start this graph? Way over here. We would call that negative infinity. And I use the parentheses because it's infinity. And I keep shading until I hit 5, but I don't include 5. Or, so we use the union symbol, I start shading after 5. So I'm going to put a 5 here, but it's in parentheses because I'm not, no closed circle on that 5. And I shade forever, which we would call infinity. So you stop and start of your shading of your included values is where you stop and start your interval notation. Last one then is another or. And for some reason I forgot my number on this. I think it's 5. Let me check here. Let's pretend it's 5. I don't actually have my notes out. I'm just doing this. So if it's a different number, you guys bear with me. Change it to 5 if you want. So I have values of x such that x is less than or equal to 5, or 7 is less than x is less than or equal to 12. That's set notation. Pretty easy to do. Interval notation, I'm going to say x is less than 5. So if I have a 5, x is less than, that means I start at negative infinity and I go all the way to 5, right? Because I always, with my domain, I go left to right. Every time. Least to greatest. Then it says or, so I'm going to use a union, or x is between 7 and 12. So 7 and 12 is where it's shaded between. 7 is not included in that value because it's a less than symbol. 12 is, so I use a bracket. That's kind of a quick version of interval and set notation, not something that you're used to using, but we will apply that to piecewise functions in our next lesson.